Now, oh, remind me to do 7 as well. I want to do one of those total energy ones as well. Plane is inclined at angle alpha to the horizontal. The particle is projected up the plane with velocity u at angle theta to the plane. Plane projection is spherical and contains the line of greatest slope. Right, that's grass is green, sky is blue, everything is normal. Prove that if the particle will strike the plane horizontally, if tan theta equals sine alpha cos alpha over 2 minus cos squared alpha. Alright, that's an interesting one. Now, this. Oh, sorry, hits horizontally, doesn't it? So, alright. So what's the landing angle? That's yeah, alpha is the landing angle. So tan alpha equals minus Vy over Vx at time of flight. Okay, so that's your goal. Time of flight, get Vy, get Vx, and put it equal to tan alpha and figure out what to do from there. Okay, there's no other way around it. Now we're going to go after u. So theta. So we got u cos theta and u sine theta. That's great. Cos theta, u sine theta. No bother. And then we gotta make our equations. So Vx. Also haven't done my gravity triangle yet, which is great. So go down here. Call that alpha. That's g. So we have g cos alpha and g sine alpha. Now we should be ready to do this. Vx is cos theta minus a half, I say minus gt sine alpha. This means Vy is u sine theta minus gt cos alpha. It means Sx is ut cos theta minus a half gt squared in alpha, and Sy is ut sine theta minus a half gt squared cos alpha. And learning from all our previous weeks, we're going to pause it here and we're going to have a good look over it again. Now, we're going for Sy equals 0. So when Sy equals 0, we're going to do ut sin theta equals a half gt squared cos alpha. Cancel the t's. Time of flight t is going to be 2 u sin theta all over g cos alpha. Okay. Now we got to take down Vx and Vy. Oh, all them are stuck together. Awesome. Right, those to rewrite the two equations down here. So we need to use Vx and Vy. So Vx is u cos theta u cos theta minus gt, so g times t. G cos alpha. Sorry, sine alpha. Alrighty. Gt sine alpha. Vx is u cos alpha. So u cos theta. See the sine alpha over cos alpha? I can turn that into, right? Turn into tan alpha, can I? Yeah. I might have to change it back. Yeah, I don't really know is the answer, but it just looks tidier for the time being. So there's no reason why I wouldn't do that. Okay. Next, we're going to go for Vy, and Vy is u sine theta minus g times t, which is our 2u sine theta over g cos alpha. And this time it's not sine alpha, it'll be cos alpha. Check and verify, done. Alright, Vy is going to be, has to be definitely negative. So the cos alphas cancel and the g's cancel. That leaves u sine theta minus 2u sine theta, which gives us minus u sine theta. Now we're going to do minus Vy over Vx for time of flight. Go back to the very beginning, we're saying it's tan alpha. So tan alpha equals minus Vy over Vx, which is going to be u sine theta, all divided by u cos theta, minus 2u sine theta tan alpha. Now, that's the easy part done. Now, what I'm going to have to do is I'm going to have to take this down with me, like so. Front page. And I'm going to have to sort of make a list of stuff that's missing from what I have compared to the answer. So let's have a good look at what goes missing. All the thetas go missing, bar on the other side. Cos theta and sin theta both go missing. Tan alpha also goes missing. Oh dear, this is going to be crazy. Okay, so this is going to be messy and crazy because I don't even know where to start yet. Right. So first thing I'm taking off is I'm going to get rid of the u's. Is everybody happy to get rid of the u's? That's an easy one. No brainer. Okay. I might cross multiply, but I'm currently not seeing any advantage to that. This has me stumped at the moment. Okay. So tan squared alpha plus theta sine theta. I'm gonna convert the 2 there and there's not 2 there. Alright. I'll cross multiply. Trying to get rid of any fractions. Alright. I need to get sine theta over cos theta somehow. Why am I trying to get sine theta over cos theta? Can anybody tell me? Have tan theta, so if I can somehow make that, that'll be a step in the correct direction. So what I'm thinking is I'm going to move all sine thetas onto one side. So tan alpha cos theta minus equals sine theta plus 2 sine theta tan squared alpha. I think I'm about to get this partially out. I'm going to factorize out sine theta. And what happens when I factorize out sine theta? I get 1 plus 2 tan squared alpha. Is that okay with you guys? And then I have cos theta over here, don't I? Now what can I do with the what can I do with that cos theta? Where am I going to put it next, you reckon? Yeah, I'm going to put it under here. So I'm going to end up with sine theta over cos theta. Is that right? And that will ensure me of my tan theta, which is what exactly what I was looking for. So I've now got my tan theta sorted. That's one part of the puzzle down. And now I have 1 plus 2 tan squared alpha. I'm going to cross multiply that back over. And I'm going to get tan alpha over 1 plus 2 tan squared alpha. Is that okay with you guys? I'm bringing that underneath. Now, I'm going to compare it directly to what they've given me. So, my biggest issue now is that they have no tan alphas whatsoever, do they? So what does that mean? All tan alphas will be converted into sine alphas over cos alphas. Alright? So you see I'm being systematic here. First thing I try to do is get that tan theta. So then I can set up my full equation around keeping tan theta on its own. Nextly, I compare both of them together. Tan alphas are all gone. Need to change them all into sine thetas and cos thetas. Sorry, sine alphas and cos alphas. So here's how this is going to look. It's going to look like sine alpha over cos alpha. That's the top part. Then it's going to be 1 plus 2 sine squared alpha over cos squared alpha. I'm going to give these guys a common denominator. So how do I do that? Can I change that 1 into? I'll change number 1 into cos squared alpha over cos squared alpha, right? That's easy enough. Okay, there's my 1 god. Now, the bottom has a common denominator, don't it? So I can bring it to the top and turn it upside down. So your next line will look something like this. Get the bottom, turn it upside down. So it's going to be, that's still going to be there. And then that's going to be cos squared alpha on top, isn't it? We're in business. Oh, bam, right. There's our sine alpha and cos alpha on top. Pleased about that. Now, what's the trick we're going to do with the bottom? What function is missing? What function doesn't exist on the bottom? Have to get rid of sine squared alpha. Any suggestions? The first time we pulled out this trick. Sine squared alpha plus cos squared alpha equals what? 1. Sine squared alpha on its own? 1 minus cos squared alpha. Double both sides. 2 sine squared alpha equals 2 minus 2 cos squared alpha. And pretty much practically out of nowhere, here's what's going to happen to the bottom there. We have cos alpha over cos squared alpha plus 2 minus 2 cos squared alpha equals tan theta. And does it basically turn into what we want? Yeah, it does, yeah. And sorry, I forgot my sine alpha on top as well, didn't I? Oh, the sine alpha was here. So the two of them are combined together. So the answer is cos alpha sine alpha over 2 take away cos squared alpha equals tan theta. And you're done.